So what we have here is kind of a more natural normal distribution probability question. We have math scores, test scores, especially for a large population, are usually normally distributed, so that's reasonable. And we know that the mean is 514, standard deviation is 103.2, and we want to know what percentage of students scored in a given range. Now, we can't use our standard normal distribution table here because that table only applies to normal populations where the mean is 0 and the standard deviation is 1. Obviously not very realistic situations. There's not a lot of real world situations that have those two particular properties. This is the kind of thing we're going to see in the real world. So how do we handle this? Well, we've got a procedure. And it's really pretty straightforward. We start by sketching a normal curve, right? Kind of sketching out the probability that we're being asked to find. Looking for, what area, what section under the curve are we trying to find the area of here? So far, it's exactly the same as we were doing before. Now, here's the extra step. We're going to take the data values and the mean, the standard deviation that we're given, and we're going to use those to calculate the corresponding z-scores. Right, and I've got the formula, just in case you need a reminder, I've got the formula for z-scores right here. Now, we're going to do just like we did before with a standard normal distribution table. We're going to take those z-scores, we're going to look those up in the table, and get the probability exactly the same way that we did in the last section. Right, so in other words, I'm thinking about this at a very high level. What we're doing is we're taking our kind of arbitrary normal distribution and we're converting it to an equivalent standard normal distribution. Then it's just a matter of looking numbers up in the table. All right, so let's look back at our SAT situation. All right, I know that my population has a mean of 514 and a standard deviation of 103.2. And the x value, the data value that I'm interested in, is 600. Right, so let's see, how are we going to do this then? Let's go over my diagram, right? Step number 1, draw a picture. So first I'm going to kind of fix this up a little bit. Right, this is my standard normal distribution graph. And I know that my mean here is not 0, it's 514. So my data value that I'm looking at is 600. That's over here somewhere. You don't have to be super precise. What I really care about is getting it on the right side of the mean, right? X equals 600 is greater than the mean, so that's the side I need to be sure I get it on. And I want scores below that, right? So that's this area here, and that's excellent because that's what I get from the table. Right, so what am I looking for? I want to find the probability that x is less than 600. Now remember how we're going to do this. I'm going to take this 600 and I'm going to convert it to a z-score. I'm going to do 600 minus the mean, it's 514, over the standard deviation. That's 103.2. And my calculator tells me this is 0.833. So remember what I said we're doing, right? We're taking this probability question about a arbitrary distribution and we're converting it to an equivalent standard normal distribution. So this is the same as the probability that z is less than 0.833. And you notice the switch that I made there, right? When I'm talking about just any old distribution, I use an x. But once I convert to that standard normal distribution, I go to using z for the variable. And that kind of helps to make it clear at what point I transition from talking about the original distribution to talking about a standard normal distribution. Now this you can just go and look up in the table, right? This is 0.796. Yeah, that matches what I'm seeing in my diagram. right? My number is to the right of the mean, so I expect this to be greater than a half, because remember, this side over here, just this half of the diagram is 0.5, and I got, somewhat more than that. Yeah, that makes sense. All right, so let's try another one here. Right now we're talking about weights, right? And I know that the mean weight of an 18-year-old male in the U.S. is 156.5 pounds. So let's get that on here. Mu equals 156.5. The standard deviation is 26.5. And the data value I'm focusing on here is 120. All right, so let's see. Again, let's fix my drawing. Right, the mean is not 0 anymore. It's 156.5. 120, that's to the left of this. So that's going to be somewhere in the neighborhood of here. So this is x equals 156.5. And I'm asked what percentage weigh more than this. All right, so now I want this side. You remember how we do a more, right? I'm going to look up the z-score in the table. When I do that, that's going to give me the area to the left. That's the part that I don't want. So I'm going to subtract that from 1, then I'll get my final answer. All right, so let's do that. Let's make the z-score here. This is z equals, this is my data value. This is 120. So my z-score is 120 minus 156.5 over 26.5, and according to my calculator, this is negative 1.377. That's good. It came out negative. It's to the left of the mean, right? And that's what we expect from z-scores on that side. All right, so now I can get to my answer. I'm looking for the probability that x is greater than 120. And to do this, I've calculated the corresponding z-score. So this is the same as the probability that z is greater than negative 1.337, which is the same as 1 minus the probability that z is less than negative 1.337. Now I can go to the table. My table tells me that that probability is 0.0842. And if I do that subtraction, I get 0.9158. And that's it. Right, that's my probability. That careful. You got to go back and read the question in the end. The question didn't ask for a probability. It asked for a percentage. Right, so my answer would be 91.58% of the population weighs more than 120 pounds. All right, so I've got one more here for us to look at, and you can pause this if you like at this point. Right, see if you can't work this out for yourself, see what you come up with. Okay, so we're working on the same kind of scenario, right? We're talking about 18-year-old males again, and I know that the mean is 156.5, and I know that the standard deviation is 26.5, and the Air Force has these requirements. Right, for a 70-inch tall person, right, that's what, 5'10", their weight has to be between 132 and 191. All right, so I'm doing a between here. All right, so again, let me go to my table. I'm going to put the mean here in the center, and I have 132 to the left of the mean. And I have 191 to the right of the mean. Make a straighter line there. and I want to know the area or the percentage in between here. You remember how we do an in between, right? I'm going to find, I'm going to look up both numbers in the table, subtract the bigger one, or subtract the smaller one from the bigger one. So what I'm looking for here is the probability that 132 is less than x is less than 191. And to do that, I need z-scores, right? So my z-score here, let me give these numbers. Let's call this x1 and x2. So this will be z1, that's 132 minus 156.5 over 26.5, which is, let's see, that is negative 0.9245. And I'll do it again over here. Z2 is 191 minus 156.5 over 26.5, which comes out to 1.3019. All right, so in other words, my probability here is the same as the probability negative 0.9245 is less than z is less than 1.3019. Again, remember how we do it between. So this is going to be the probability z is less than the bigger number minus the probability that z is less than the smaller number. Now I'm going to my table. This is 0.903522. I say go to the table. I usually do these in Excel, right? So Excel gives me a lot more digits of accuracy than the 4 you get from the table. That's why sometimes I go out further. Mine is 0.177606, and that difference is 0.7259. Or we were asked, go back to the question, we were asked for a percentage. 72.59% of the population falls in the Air Force's acceptable range. Excuse me, Air Force ROTC's exceptional range. So let's actually go back here and take a look at this for just a second. And let's see if I can't make my drawing a little more precise. Right? The negative score was negative 0.9245. So that is not quite a whole standard deviation below the mean. The positive z-score was 1.3. So that was not quite 1.5, but close to it. Right? So what I'm seeing from this, right, there's more area over here on the above the mean side than there is over here on the below the mean side. In other words, it looks like the Air Force, for whatever reason, is more tolerant of people who are I hate to say overweight, but people who are above average in weight than they are people who are below average in weight. Okay, so what's next? Well, here we've been focused on answering this question, what's the probability of? Well, in the next section, we're going to go the other way, right? We're going to be given, well, not usually a probability. Usually we'll be given a percentage of the population. And we'll be asked to find what data value has that percentage below it. Remember, the percentage that has a certain amount of the data below it, that's called a percentile. Right? So that's another term that's going to kind of pop back up here in that next section.